चल, so we all did the preparation from alkenes, beta. We all did the preparation from alkenes. How to prepare alkyl halides from alkenes? Let's say we have any alkene. And we put in this alkene, what we put in this alkene? HCl. So you all know if simple HCl is there, H will come this side and Cl will come this side according to Markovnikov's rule. According to Markovnikov's rule, this will happen. If you have alkene. And according to anti-Markovnikov's rule, let's say we have HBr in H2O2. So this Br will come this side and H will come this side. ये याद रखें आप लोग हमेशा. This Br will come at less substituted side and this is what? Anti-Markovnikov. This is anti-Markovnikov. Then, so today we will start our new thing in which we do what? Let's see. Our new reaction we will start. Let's see. I have CH3 double bond CH CH2. If I have this thing and I put in this Br2 in FeBr3, Br2 in FeBr2, or I put in this reaction Br2 in CCl4. If I have this, and if I have an alkene, and in this alkene I am putting Br2 FeBr2 or Br2 CCl4. So what will happen? So यहाँ पर क्या होगा? यहाँ पर this double bond will be broken from here. This double bond will be broken from here, and Br will come on both the carbons, and Br will come on both the carbons. And this reaction is known as electrophilic addition of alkenes. And this all you have learned in alkenes chapter, electrophilic additions of this alkene. Matlab Br2 will come, both Br will come and attach here. So you should know कि इसका mechanism, how this mechanism happens. देखें इसका mechanism कैसे होता है. Let's say we have this CH double bond CH2. You should know whenever you have Br, यहाँ पर ये double bond Br के attack करता है. This double bond will attack the dipole of this Br positive. The double bond is acting as a nucleophile. It will attack the del positive of Br. है ना. तो यहाँ पर del positive का करके यहाँ पर if it attacks, तो यहाँ पर ये it makes here a cyclic bromomium ion. है ना. यहाँ पर ये एक cyclic ब्रोमोनियम आयन बनाता. यहाँ पर दिस डबल बॉन्ड के साथ ये 3 डिग्री यहाँ पर साइक्लिक 3 मेंबर रिंग कहते हैं इसको, साइक्लिक 3 मेंबर्ड रिंग बनाता. दिस इज आर इंटरमीडिएट इन दिस रिएक्शन, और 3 मेंबर्ड इसको कहते हैं ब्रोमोनियम आयन. Bromine positive on bromine. Now what will happen? This Br minus which was left, इसने इसके ऊपर अटैक किया, Br minus को अकेला छोड़ दिया. These electrons, this Br minus will attack again this carbon. है ना. अगर इसने इसको अटैक किया तो this bond will be shifting towards Br. है ना. And this attack is known as anti-attack, opposite attack. है ना. एंटी हो जाएंगे, और यहाँ पर ये वाला Br इधर आएगा एंड ये वाला Br will be opposite to each other. These two Br will be opposite to each other. है ना. These two Br will be opposite to each other. Opposite Br. है ना. And this, from this only we will come to know that these two Br has broken the bond of alkene and substituted them here. And this is only known as addition of alkenes. इसको क्या कहते हैं? Addition of alkenes. We added both the bromine on alkene. We added both the bromine atoms on the alkene. है ना? अगर हम लोगों ने यहाँ पर we added both the bromines on the alkene. So this is also known as this reaction is also for the test for unsaturation. This is also the test for unsaturation. Unsaturation means what? Unsaturation means whenever you have double bond, triple bonds, this is known as unsaturation. And whenever you have double and triple bond, this is known as unsaturation. And this is one of the tests. Let's say you have alkene and you put bromine in CCl4. है ना? तो ये क्या करता? बोथ कार्बन के ऊपर ब्रोमीन दे देता है. And the color of the bromine, which is dark brown, disappears. So what happens whenever we have an alkene, and if I want to test that my compound has alkene or not, so I put Br2CCl4 in that reaction. If in that reaction, the color of bromine disappears, है ना? This bromine is not there, है ना? अगर वो bromine goes and इलेक्ट्रोफिलिकली एड ऑन एल्कीन, अगर दोनों एल्कीन के ऊपर ऐड हो गए, बोथ एल्कीन के ऊपर ऐड हो गए, तो ब्रोमीन कलर डिसअपियर्स, है ना? एंड दिस इज ओनली द टेस्ट. अगर मेरे पास लेट्स से आई हैव एन ऑर्गेनिक मॉलिक्यूल एंड इट इज गिविंग अस डिसकलरेशन ऑफ ब्रोमीन, है ना? ब्राउन कलर, डार्क ब्राउन कलर. इफ color of bromine, if dark brown color of bromine disappears, this will tell us that the organic compound contains alkene in that reaction, है ना? This is one of the tests for alkene. हम लोग देखते हैं. Next reaction, you can write this as fast as possible. लिख सकते हैं आप लोग. I'll give you 30 seconds to write. जल्दी लिखें. I'm giving you 30 seconds. Write this, बेटा. So beta, what happens यहाँ पर? Bromine act as a dipole, and whenever we have beta partial del positive and del negative, तो ही यहाँ पर, है ना, we can't make this as free radical mechanism, है ना? We can't make this as free radical mechanism when question is asked by student. So we have to take this bromine as dipole moment, क्योंकि अगर let's say कोई वहां पर, let's say any organic molecule is coming, that is only making the induced dipole in bromine. Bromine does not have its own electronegativity difference, but when this compound, this alkene approaches to the bromine, so this is induced dipole, है ना? Induce किया उसने dipole को induce किया, and then this bromonium ion will be formed, है ना? We will take your mark your questions. We will take the doubts in the last of the term. Next one, see beta. Similarly, let's say we have CH3, CH, CH2, and it is given Cl2 in FeCl3. When Cl2 in FeCl3 it is given, we should know कि अगर यहाँ पर हुआ तो यहाँ पर both Cl will come and will make the addition reaction. Both Cl will come and make electrophilic addition. This is what? Electrophilic addition. Electrophilic addition. And mechanism you also know. Mechanism अभी हम लोगों ने किया है. We make cyclic bromonium ion ऊपर हमने बनाया. Similarly यहाँ पर क्लोरीन का बनेगा. Similarly यहाँ पर क्लोरीन का बनेगा. Again last thing I am telling, देखें one more reaction. Let's say we have this alkene, and if I put in this alkene Cl2 with heat or light, है ना. अगर heat light होता है, we always remember we have to make free radicals. We have to make free radicals. अगर यहाँ हमारे पास free radicals we need to make, and this is free radical mechanism, है ना. If we have Cl2, if I give Cl2 with H nu or heat or light, है ना, heat light के साथ heating if we have done in this reaction, so what will happen in this reaction? देखते हैं. So what will happen? This ClCl will break homolytically, beta. Homolytic cleavage will happen. Cl radical and Cl radical will be break, है ना. So this Cl radical and this Cl radical will induce here. Let's say I write the direct product first. Writing the product first, then you will come to know, है ना. So what the Cl radical will do, it will try to break the Cl radical. Initiation was done by Cl radical. Now Cl radical will try to propagate this reaction by making radical on this compound. If I make radical on this compound, my main priority should be stability of free radical. Stability of free radical. है ना. So let's say we have to break CH bond anytime. We have to break CH bond. We can't bring CC bond. We have to break CH bond because CH bond is more यहाँ पर polar है. और let's say we have this और ये पर CH2, है ना. So if I break this bond from here, अगर मैं यहाँ पर ये वाला bond break कर रहा हूँ, homolytically I am breaking homolytic cleavage. So this Cl will take the H radical from here and will make HCl, and this radical will be made which will be in resonance with double bond. Free radical, sigma bond, then double bond, resonance. We have learned in resonance, whenever we have free radical, sigma and double bond, pi bond, this is the condition of resonance, and this only can make resonating structure. और यहाँ पर it can make double bond this side and it can make CH2 radical this side. See, therefore, due to resonance, this allylic, this is which radical? Allylic radical. Allylic free radical is more stable, है ना. Due to resonance, this allylic free radical will be more stable, and once this allylic free radical is made, this allylic free radical हमारे पास बन गया. So one Cl was gone with HCl, another Cl minus will come and attack on this free radical and will make CH2 Cl this side, and then we have CH2 and H this side, है ना. तो यहाँ पर ये देखें. So our main product when we are making this reaction, when we are doing Cl2 in heat and light, we always add Cl at allylic position. We always add Cl at Allylic position where free radical was more stable, where free radical was more stable, है ना? Similarly, वे एक और example, let's say I have one more example I take. Let's say this is our benzene ring, and I am putting in this Cl2 in H nu or heat, है ना? I am putting in this Cl2 H nu or heat. So our result will be Cl will be coming CH2 and Cl. CH bond will be broken from here and Cl bond will be made in this reaction. है ना? इसका मैकेनिज्म you all know. अगर हम इसका Cl2 का फ्री रेडिकल मैकेनिज्म होता, we have free radical mechanism. अगर free radical mechanism है, Cl will break to Cl radical, है ना? And this Cl radical will initiate here to make radical, and which radical will be made? This benzylic radical will be made, beta. This benzylic radical will be made. This will be broken to make this benzylic radical, CH2 radical, because this is in resonance. This is in resonance with the benzene. This radical is in resonance with the benzene. We have learned this in resonance. We have also made the resonating structure of this benzene. है ना? So this radical will be made and HCl will be made of first Cl. Now again Cl radical will come and combine here. है ना? So यहाँ पर CH2 Cl will be made on the above carbon, है ना? Similarly, एक और example, let's say. So important thing, beta, summary I am telling you here. Let's say we have benzene के ऊपर CH3. This is known as toluene. In toluene, if I put chlorine with H nu or heat, in toluene, if I put chlorine with H nu or heat, we always add chlorine where? We always add chlorine at the benzylic carbon. At benzylic carbon. Always remember, है ना? Again, I am telling, if I am adding chlorine with H nu, this is free radical mechanism, it will always go through this benzylic. One more last comparison we will try to see. देखें. One comparison we will try to see. But I will take your questions in the last. You can write your questions in the chat box. I will take your questions. Okay, but I will give time to write. Don't worry. I'll give you the time to write. Slowly we will go. Slowly we will go. Don't worry. I will give you the time to write, but don't worry. You will get these notes. Don't worry. देखें. Last thing we will see. First, last comparison we will try to see. देखते हैं ये वाला comparison. Let's say we have CH3. You try to understand beta first. पहले understand करना देखें. Let's say we have this alkene. In this alkene, I put Cl2 in H nu or heat. If I put Cl2 with H nu on heat, this will be our free radical mechanism. Because of H nu and heat. And our Cl will come where? The Cl will come at the allylic position. Allylic position पे आएगा यहाँ पर, है ना? यहाँ पर ये allylic position पे आएगा Cl because the free radical stability. And if I put in this reaction Cl2 with FeCl3, है ना? अगर मैं यहाँ पर Cl2 with FeCl3 put करता हूँ, so this will be heterolytic cleavage, बेटा. This will be heterolytic cleavage. And what will happen here? Addition of alkenes, electrophilic addition will happen. Electrophilic electrophilic addition will happen in this, है ना. मीन्स इलेक्ट्रोफिलिक एडिशन मतलब Cl will break और यहाँ पर क्लोरीन का पॉजिटिव बनेगा, देन Cl will come and attack and this will give us chlorine added on both the carbons, है ना. So if I use in the reaction, therefore always remember, if I use in the reaction chlorine with FeCl3, any reagent I use, so heterolytic cleavage will be happening and electrophilic addition will be happening in that reaction, है ना. electrophilic addition होता है उस reaction, है ना. और if I have Cl2 with HNO, so यहाँ पर होमोलिटिक क्लीवेज होता है, यहाँ पर होमोलिटिक क्लीवेज होता है, फ्री रेडिकल मैकेनिज्म होता है, होमोलिटिक क्लीवेज होता है, वी हैव फ्री रेडिकल मैकेनिज्म, वी हैव फ्री रेडिकल, है ना. So always remember, when you use heat light in the reaction, you will have homolytic cleavage, you will have free radical mechanism. And if I use any reagent with chlorine, with bromine, let's say I'm using bromine Br2, for that I have to use FeBr2, FeBr3, है ना. और दूसरा reagent of Br reagent I need to use any Lewis acid, ठीक है. So if we had Cl2 with any reagent, है ना, without heat light, for in that condition this both Cl will come and add on alkene को हटा के both Cl will come on both the carbons. But if I have Cl2HNO, so we should have homolytic cleavage, stability of free radical we will see, and the Cl will come at the allylic position. So I will give you 2 minutes to write this reaction in your notebook. Very important in this bit. लिख लें. If you have any question, you can write in the chat. Yes, beta, I will upload all these notes in the group. Yeah, beta, it is mostly possible for chlorine and bromine. For fluorine, it is not possible because fluorine carbon-fluorine bond is more stronger. So for fluorine, we have not seen. है ना? For iodine also, it is not mostly possible because iodine reactivity is very low, beta. Then I will explain the test for unsaturation again, beta, don't worry. है ना? Test for unsaturation is, let's say we have bromine. In that test for unsaturation, we always use Br2CCl4. In that the color of bromine, in the starting we put bromine, in that the color of bromine will disappear in alkene. So this only will tell us that the compound which I have taken, that was alkene, है ना. अगर bromine चला गया, so that was alkene. The color of that bromine will disappear. Next thing we are writing, चले. So you should know better from above only. You should know from alkene से how we are preparing from alkene. Next reaction I am writing. Second reaction लिखेंगे. Second reaction I am writing. Let's say we have CH3, CH double bond CH2. And in this reaction, if I use NBS, इसको कहते हैं N bromo succinamide, NBS है ना. This is a reagent which will use. I will draw the structure of N bromo succinamide. देखें, we have N at N bromo, and this group is known as succinamide, amide group. Succinamide from succinic acid. And if I made here OHOH, this will be succinic acid. But if I made amide, and a CONH2, this is succinamide. And if I put NBS in this alkene, if I put NBS, this Br will come at the allylic position of this Br will come at the allylic position of, yeah beta, you can write, don't worry, you beta, leave space for writing. You can write afterwards also beta, leave space, छोड़ते जाएं. I will give you just after the class, I will give you the notes, है ना, you can complete the notes fast. So if I use NBS in this reaction, so bromine will come at where? Allylic position. So always remember, whenever we add NBS it is written N bromo succinamide. Always add bromine at allylic position. This is also free radical mechanism. We don't go much into mechanism. This is also one of a free radical mechanism. आपको ज़्यादा जरूरत नहीं है. Same mechanism it will be. Br radical will be made, and Br radical will help us to make allylic free radical. यहाँ पर allylic free radical will be made, which will be in resonance. Because of resonance, this Br will come. है ना? Similar mechanism this is. One question you have to solve. Let's say we have this benzene ring and we have ethyl group on benzene ring. If I put in this ethyl group, NBS, if I put in this reaction, this is N-bromo succinamide. If I put in this reaction, so what will be our product? Write the product here. Write the answer product here. Just, I'm giving you 1 minute, write the product. Always remember, when you have bromine or alkene, it will come at allylic or benzylic. You have to see the free radical stability on which it is more stable free radical. On that it will be. चलो, किया आपने? Write yes or no in the chat box. Write yes or no in the chat box. Write yes or no in the chat box. Beta, this NBS is a free radical mechanism. This radical will be made where to make radical more stable on this benzene ring. Our radical will be made more stable on this benzene ring where this, if I break the carbon and hydrogen bond here homolytically, this radical will be made here. And with this, our Br, this Br radical will be coming here. So answer of this will be C. Answer of this will be this CH, H and CH3. This CH and CH will be broken, है ना, ये ब्रोक होगा यहाँ से, and our Br will come and make bond here, and our Br will come and make bond here. So Br तो यहाँ पर आता है ना, देखें, and this carbon will be made a chiral carbon. Check from here. This carbon will be made chiral carbon. All the four groups different. Hydrogen, bromine, CH3 and phenyl group. है ना? You can write this bit in your note. We'll go slowly, slowly. We will go slowly, slowly, and slowly, slowly. We will try to go. Don't worry. It's as simple. Very simple. It is. So if someone used NBS in the arrow reagent with alkene, you should always add bromine at allylic or benzylic position. Always add bromine at allylic or benzylic position. Add bromine at allylic or benzylic. And allylic and benzylic position, you all know which is allylic and benzylic position. First class I have taught you. The position with next to the double bond is allylic, and the position just outside the benzene ring is benzylic. यहाँ पर जो first carbon which is, it is the benzylic, because here free radical will be going in resonance, therefore it will be. Okay. So with this, our preparation from alkenes is over. From alkene, I can prepare with HCl, with Markovnikov rule, anti-Markovnikov rule, or I can do with Br2 FeBr3, इलेक्ट्रोफिलिक एडिशन ऑन एल्कीन्स. दोनों के ऊपर एल्कीन डाल के हमें यहाँ पर दोनों ब्रोमीन मिल गए, है ना, वी गॉट बोथ द ब्रोमीन्स हियर. और आई कैन डू, this is also the test for unsaturation, or I can do what? I can do the free radical mechanism with Cl2H nu or heat, है ना. free radical mechanism के लिए we should always have heat or light. On this free radical stability we need to see, or allylic and benzylic free radicals are always more stable, है ना. allylic and benzylic radicals are always more stable. Let's say we take toluene also, we put Cl2H nu, so Cl will come here. यहाँ पर free radical CH free radical will be made and Cl will come. And this main important thing we have learned, if we have an alkene, if I put alkene के अंदर Cl2H nu डालता हूँ तो Cl will come at allylic position. If I am putting with Cl2 FeCl3 any reagent, so this Cl will be acting as electrophilic addition reaction and it will go for heterolytic cleavage, or Cl will be adding on both the carbons. Cl will add on both the carbons. Last one was NBS. If I use NBS and bromosuccinamide in the reaction, so यहाँ पर we have free radical mechanism and we add bromine at allylic position and benzene. So this was our preparation from alkenes. Last one we are doing the next preparation from next see. This is our fifth preparation. देखें, if I am preparing our preparation of alkyl halides from amines, if I am preparing my alkyl halides from amines, देखें, if I am preparing my alkyl halides from, let's see, if I am preparing from alkyl halides amines, you all know amines functional group is NH2. NH2 is the amine functional group. If I have amine, if I put in this amine, हम यहाँ पर put करते NaNO2 plus HCl, है ना. If I put sodium NaNO2 plus HCl at 0 to 5 degree temperature, 0 से 5 degree means very low temperature. If I put in this very low temperature, यहाँ पर we prepare here CH3N2 positive and Cl minus, है ना? We prepare this from this reaction. This is known as what? Diazonium salt. And this is known as diazonium salt. And this diazonium salt of alkyl groups, this alkyl diazonium salt is very unstable. This is very unstable in nature. अगर ये अनस्टेबल है, अगर ये अनस्टेबल है और इसको and we put in this reaction, let's say water, we put in this reaction, let's say water. So what will happen? This nitrogen will come, this nitrogen N2 positive, yeah, will come out as nitrogen gas, and we are left with CH3. We are left with CH3. We are left with CH3 and OH, है ना? Mechanism is not required. And earlier other further classes also we will understand the diazonium salt mechanism. In this class, you write this, the reaction of CH3 CH3OH. Once this CH3OH is made better, अगर एक बारी alcohol बन गया, from alcohol you all know, if I want to convert this alcohol to alkyl halide, what I can do? I can use Lucas reagent. I can use different types of things which I told in last classes. So let's say I use concentrated HCl with anhydrous ZnCl, है ना? अगर मैं ये करता हूँ तो ये क्या होता? OH का यहाँ पर H positive पर अटैक करके free carbokation will be made and this Cl minus will come and attack at CH3 to give us CH3Cl, है ना? ये आपको याद करना है, very important this is, है ना? So this is our main product. If I want to make alkyl halide from amines, this is amines. If I want to make alkyl halides from amine, तो हमें क्या करना है? We need to make diazonium salt. Alkyl diazonium करके we put water into alkyl diazonium. We make alcohol. We make alcohol, and from alcohol I can do Lucas reagent. I can use Lucas reagent or any reagent associated to other reagents also we can use, and we can convert to alkyl. है ना? Write this in your copies. I'm giving you 2 minutes to write. Better mechanism will come in further classes, don't worry. In amines we will study this mechanism. Written, write yes or no in the chat box. Write yes or no. Beta NBS, we use NBS to add bromine only, beta. We can't add chlorine. NBS you have and bromosuccinamide. So you can add bromine. Beta, why NBS is free radical mechanism out of your syllabus, beyond your scope? It is there. बस याद करे थोड़ा सा. Little beyond your syllabus. Yes बेटा, there is no heat and light in NBS. It is beyond your syllabus. थोड़ा सा out of syllabus है, थोड़ा सा याद करें यहाँ पर. But I will give you the questions which is asked. I will give you the homework. Do the homework. You will come to know how the questions are asked. Do the homework. You will come to know. In NBS, we don't need to give heat and light. We put NBS directly. Questions are many, beta. In this questions are many. I will give you questions list. Don't worry. Many questions are there. Chal. Next thing, beta. This was from preparation from amines. Next one is preparation for from carboxylic acids. You will see this. Take. Next one, this was the fifth one. This is the sixth preparation. Preparation from carboxylic acids. Preparation from carboxylic. देखिए, let's say we have one carboxylic acid, है ना, ये वाला, and I put in this Ag2O, silver oxide. Ag2O is what? Silver oxide, है ना. If I have this Ag2O, यहाँ पर क्या होता? This O minus and Ag positive will become, and this is known as silver salt of carboxylic acid. It makes silver salt of this carboxylic acid. And once this silver salt is made, and in this silver salt, I put Br2 in CCl4. If I put Br2 in CCl4 in this silver salt, so what will be made? Directly you can write from here RBr plus CO2. देखें, RBr plus CO2 and Ag positive will be again gaining from here. है ना. If I want RBr को नहीं, if I want from here, wait just a minute. Just है ना. If I want to convert from this carboxylic acid, to what? Alkyl halide. To alkyl halide, I can use silver oxide in the first step, first reaction. So this silver oxide, what it does, it will make silver salt of carboxylic acid, है ना. इसने silver का salt बनाया, and if I put in this reaction Br2CCl4, and once I put in this reaction Br2CCl4, the CH3CH2Br will be made, and CO2 will be gone out of the reaction, and Ag positive, again that salt will be made from again, है ना. और देखें अब this reaction is one of the name reaction. इसको हम लोग हंस डिकर reaction कहते हैं. हंस डिकर reaction. The name of this reaction is हंस डिकर reaction. लिख लें. In this reaction we have decarboxylation. In this reaction we have decarboxylation, means loss of CO2. Decarboxylation means loss of CO2 derivatives, है ना. This is also from free radical mechanism. This is also from free radical mechanism. देख लें अभी. This is also from free radical mechanism. These two are totally different reactions. यहाँ आप लोग अभी लिख लें. Just write them. I will tell you. The mechanism is not there, mostly not there in your syllabus, but it is given in your module. You can check. You can go and check. Don't worry. Little beyond your now levels, but if you are preparing for advanced, you will teach you. For advanced, it is there. Teach you. पर यहाँ पर अभी we need to cover our things. Write this reaction within 2 minutes, right? So with this beta, your preparation of alkyl halides is over. We have done 6 preparation. We'll write the summary also. And homework I will give to you of the preparation of alkyl. Yesterday's homework you will come to know how to solve these reactions. In the last 15 minutes, I will unmute you, then you can ask your question. 2 minutes more I will give you, right? Then should we start? Next. Right, yes or no? Sure. So see last bit of summary, see. Summary beta see. Fast I am writing. Summary, we prepared from alkyl halides from alkanes, which was all about chlorination, bromination, iodination, chlorination. Second, we prepared from halogen exchange. We have 2 reactions in halogen exchange. One was Schwartz, other was Finkelstein. Beta, you have to learn this reaction. What is the reagent? What is the things? What you have to make? Everything you have to learn. Third thing was from alcohols we made. From alcohols we use Lucas reagent. You know, we use different types of all range like PCl5, PCl3. We use NABr, KBr. You know, again repetition. I am doing all the same things beta. You know, we have SOCl2. We use SOCl2 plus pyridine. Different mechanism they have. This is known as Darson reaction. You know. After this, from alcohols, we made from alkenes. From alkene. From alkenes, we learned the rule was Markovnikov's rule. Markovnikov's rule. Second rule was anti-Markovnikov's rule. You should know where to use Markovnikov, where to use anti-Markovnikov. The third one was from alkene. क्या था third one? Third one which we have used was NBS and bromosuccinamide. Today only we did NBS. We did, है ना? Very important reaction it was NBS reaction. उसके बाद हम लोगों ने एक ICL वाला भी किया. We did one ICL reaction also. ICL वाला भी किया with free radical mechanism it was. Last one from alkenes. Last fifth one we prepared from amines. If I am making from amines, we have to make diazonium salt, and from alcohols, once alcohol is made, adding water into that, you have to convert that alcohol into alkyl halides. You should know by diazonium salt we need to prepare. By diazonium salt. Sixth one was from carboxylic acids. Sixth one was from carboxylic acids, which is the last reaction we studied today. This is the Hunt-Sticker reaction. Hunt-Sticker. So these was all about the preparation of alkyl halides. You can take screenshot or you can take, this was all preparation of two classes which we did. Previous two classes. देख सकते हैं. This was the summary of previous two classes which we started telling. Challenge, should we go forward? Write yes or no in the chat box. Yes or no, write in the chat box. Should we go forward? Sure. Simple, this was not much difficult. Simple, simple. Once you are able to write fast. Those who have not written, write fast. In evening session on top, there will be an evening session of organic chemistry. When ma'am of other branch is taking, better try to see. Is teaching something of GOC and all. So try to learn from there also if you have time. Take that session. It is more of practice session to you. You will learn all hyperconjugation, resonance, mesomeric, all things. But if I will get extra time, I will take extra class someday. I will teach you hyperconjugation resonance. Resonance was simple. Inductive is also simple. Mesomeric I will teach you, don't worry. Next thing, beta, we will try to write next is the next thing is beta preparation of aryl halides. Aryl halides, or also you can write in the presence of aryl halides, you can also write haloarenes. Haloarenes we कहते हैं. So what are haloarenes? क्या होता है? Let's say we have benzene aryl group and I have, let's say, X group on benzene. So X can be what? Fluoro, bromo, or iodine. series. And if I have this fluoro, it is known as fluorobenzene. If I have chloro, it is known as chloro. If bromo, then bromobenzene. If iodo, then iodobenzene. Then देखें. So let's say I have on the benzene chlorine. I have on the benzene chlorine. So see beta, this chlorine is attached to the carbon which is sp2 hybridized. sp2 hybridized carbon. है ना? And the resonance which is occurring is lone pair and pi conjugation is there. So this lone pair of chlorine can go in the conjugation in the resonance of this benzene. So if it goes in the resonance, we all have made this resonance in our previous classes. Let's say this lone pair will attack here. This double bond will come on carbon atom. है ना? So if this come on carbon atom, it will make negative. This will become double bond. Chlorine will become positive. The rest all bonds same. है ना? Again, negative on single bond, double bond on carbon atom. Our rule, our thing, our song which we have prepared in last class. Negative on single bond, double bond on carbon atom will make negative. है ना? Similarly, write by yourself all the resonating structures of this chlorobenzene. Negative on single bond, double bond on carbon atom make. And the last one will be this negative will come here and double bond will jump on chlorine to make us the benzene ring with electrons are changed. Take there, and this chlorine. So thus the movement of electron was done from resonating structure from here to other side. Electron, 6 electrons of this benzene ring has changed its positions. Simple. है ना? देखिए. See beta, due to this resonance only, due to this resonance, carbon and chlorine bond will be what? Partial, partial, it has partial, it has partial double bond character. It has partial double bond character. Because this alkene, these lone pairs of chlorine are coming from up to down, or इसमें in the benzene ring, it is activating the benzene ring, giving the electrons to the benzene ring. The bond between carbon and chlorine, this bond between carbon and chlorine, will become partially double bond. है ना? मतलब डबल बॉन्ड से कम, सिंगल बॉन्ड से ज्यादा, है ना? Because of resonance. So it will have double bond character due to what? Because of resonance. Because of resonance, or you can say mesomery. Mesomery के कारण of Cl, है ना? So you should always remember कि यहाँ पर जो डबल बॉन्ड, जो यहाँ पर सिंगल बॉन्ड होता है, ये सिंगल बॉन्ड नहीं है, it is more of partial double, है ना? Write this in your copy. चले. So now we will try to see the preparation of alkyl halides. How can I make X here? So now how can I make alkyl halide from it? The first method everyone has remembered, method of preparation. Let's say I have a benzene, and if I want to make from benzene this chlorobenzene, and this is known as what? All you have remembered, this is known as chlorination of benzene. Chlorination of benzene. But how can we do this reaction? क्या करते हैं यहाँ पर? We have to put Cl2 with anhydrous AlCl3. This all you have remembered in your class 11th it was, and this reaction was known as electrophilic aromatic substitution reaction. Electrophilic aromatic substitution reaction. Electrophilic aromatic substitution. देख लें बेटा. Sure. On benzene, if I am doing this reaction, so we will see the mechanism. You all know the mechanism also. Mechanism was what? Let's say we have chlorine and chlorine. So this will be del positive, this will be del negative. And AlCl3 is a Lewis acid. It can take lone pair of electrons in its d orbitals. So इसको यहाँ पर attack हुआ, and Cl positive made here, and AlCl4 negative will become, है ना? तो यहाँ से the bond of Cl2 Cl will be broken from here, and AlCl4 negative will be made, and Cl positive. And this Cl positive is known as our electrophile. So in the given reaction, we have our benzene, Cl positive, and AlCl4 negative. See, benzene is more nucleophilic in nature. It has electrons, rich in electrons. So now the benzene will attack on this benzene double bond will try to attack on Cl further, है ना? तो ये यहाँ पर attack करता, this double bond will shift this side, negative will come and will attack on carbon, chlorine here, and this all will be, and this positive will be made here, है ना? So this double bond which was present here, when it all shifted towards this side, it attacked on chlorine and made chlorine bond, और यहाँ पर this carbocation was made on carbon. This carbocation can go in resonance only half, है ना? इसको ही हम लोग अरीनियम कॉम्प्लेक्स कहते हैं. अरीनियम कॉम्प्लेक्स. Just write this, beta. This all was in your class. And in the ending, what will happen? This FeCl3 4 negative, this will take the hydrogen and will again give the double bond and will change the bond from CH to Cl. So the bond of CH from here was broken and CCl bond was made on benzene. है ना? This is known as electrophilic addition reaction on benzene, है ना? इसको प्यार से मैं, if I ask, it is also EAS. I used to call it EAS, electrophilic addition substitution reaction. Substitution reaction. मतलब CH was substituted with CCl. The bond of CH was broken and was made CCl, है ना? CCl को बनाया CH को तोड़ के. है ना. So this is what substitution. एक की जगह पे दूसरा आ गया. Cl was substituted in replace of hydrogen. And in some books it is also written ARSE. ARSE means aromatic substitution and electrophilic. Aromatic substitution electrophilic. Aromatic substitution electrophilic. So just see. Write this in your notes, beta. Type in it, beta. Don't worry, you will get the notes. You will get the PDF. चलो, written this all. So beta, you should remember this electrophilic aromatic substitution आपको कराया है. This all was done. Let's say I have a benzene. Let's say I have a benzene, and if I put in this benzene, this all was done, beta. Fast, I am also writing. देखें. If I put in this benzene, chlorine with FeCl3 or anhydrous AlCl3 or anhydrous FeCl3 or anhydrous AlCl3, anything, or this is or, है ना? Chlorine plus FeCl3 or anhydrous AlCl3, we will get what? Chlorobenzene. This is known as chlorination of benzene. Chlorobenzene कहते हैं इसको. Let's say if I give you CH3Cl plus anhydrous AlCl3, है ना? ये यहाँ पर कौन सा रिएक्शन होता है? We will get on the benzene CH3 plus HCl, and this reaction is known as Friedel-Crafts alkylation reaction of benzene. Friedel-Crafts alkylation of benzene. And this all was in your last classes. This is all what? EAS of benzene, electrophilic aromatic substitution. Electrophilic aromatic substitution. This CH hydrogen is replaced by some other substitution groups. है ना? ये CH वाले को substitute करके कोई और group लगा. This is electrophilic aromatic substitution. First was chlorination. Next was Friedel-Crafts alkylation. Next एक और देखें. Let's say we have CH3COCl with anhydrous ClCl3. This all you know. This is known as what? We put COCH3 on benzene ring, and this is known as what? Friedel-Crafts acylation. We put acyl group on the benzene. This is acyl group. This is known as Friedel-Crafts acylation. Next we have concentrated HNO3 plus concentrated H2SO4. है ना? अगर ये है हमारे पास तो हमारे के बेंजीन रिंग के क्या आएगा? NO2 will come on the benzene ring, and this is known as nitration of benzene. Nitration of benzene. If you want to get NO2 on the benzene, you have to do nitration. Last one, see, let's say we have concentrated H2SO4 or oleum, OLEU. So we will get on the benzene ring SO3H. And this is known as sulfonation. This is known as sulfonation of benzene. So these all reactions are electrophilic aromatic substitution of benzene. What we have substituted? We have substituted, these are what? These are electrophiles. These are electrophiles. So यहाँ पर electrophile SO2 SO3 है, यहाँ पर electrophile NO2 पॉजिटिव है, यहाँ पर electrophile CH3 CO पॉजिटिव है, यहाँ पर electrophile CH3 CO पॉजिटिव है, यहाँ पर इलेक्ट्रोफाइल CH3 पॉजिटिव है और यहाँ पर क्लोरीन पॉजिटिव है इलेक्ट्रोफाइल, यहाँ पर क्लोरीन पॉजिटिव है. So this CH will be removed and these electrophiles will be added in the benzene. And write this. Write yes or no after writing, beta. Beta, all this was explained to you in class 11. सर ने समझाया है सब कुछ. सल्फोनेशन ये सब समझाया है, बेंजीन के ऊपर सल्फोनेशन कैसे होता है सब समझाया है. एवरी मैकेनिज्म वाज टोल्ड, है ना? Don't worry, beta. Again, this will come again and again. It will come in forward classes. I will teach you all electrophilic aromatic substitution in one class only. सारे सीखेंगे. This is just the show of previous class. So if I want aryl halide from benzene, I have to give Cl2 FeCl3. Then only we can go forward. If I want chlorine to come on benzene, I have to give Cl2 anhydrous AlCl3 in that reaction, or FeCl3 in that reaction to give us chlorine. Chal. With this done, one question here only, beta. Very important this is. In last class also we studied. Let's say we have CH2CH3. In this reaction, I put. Wait, just. If let's say I have CH2CH3, in this reaction, I am putting Cl2 with H nu or heat. Cl2 with H nu or heat angle. So Cl will come at the benzylic position. है ना? So Cl will come here at the benzylic position. In the same reaction, if I am putting in this reaction, let's say, if I am putting Cl2 anhydrous AlCl3. If I am putting Cl2 anhydrous Cl3, so this will be our Friedel-Crafts, है ना? Right. This will be our what? This will be our chlorination. This will be our chlorination. और क्लोरीनेशन करना, so we have to see the chlorination. If I want to do the chlorination, we have to see that this group is acting as what? Ortho para director or meta director, है ना? तो अगर क्लोरीनेशन करना है, दिस वाज, अगर क्लोरीनेशन करना है तो हमें देखना पड़ता कि दिस इज एल्काइल ग्रुप, आर ग्रुप, दिस इज प्लस आई ग्रुप. इफ दिस इज प्लस आई, इलेक्ट्रॉन डोनेटिंग ग्रुप, इट विल ऑलवेज एक्ट एज ऑर्थो पैरा डायरेक्टर, है ना? सो ये क्या करता, दिस CH2CH3, this will divert the Cl positive, chlorine positive electrophile which was made in this, है ना? The electrophile which was made in this towards ortho position or para position. So these two products will be formed, and the para one will be the major and ortho one will be the. So always remember, whenever we have any group on benzene, है ना? If we have any group on benzene, that group will divert the electrophile towards ortho or meta. If the group is plus I plus M, if the group, and if the group is plus I plus M groups, so these are all ortho para director. If the group is minus I minus M, these all are meta directors. Meta director मतलब ये आने वाले इलेक्ट्रोफाइल को कहता कि you go at meta position, you go at para position. So the person sitting on the benzene will tell कि the electrophile will come where? The electrophile will come where? Another person sitting on benzene, the group present on benzene will tell us, the group present on benzene will tell us that it should come, electrophile should come at ortho or para or meta, है ना? This is ortho position, this is the para position, है ना? तो अगर ये यहाँ पर दिस प्लस आई ग्रुप इज देयर, CH2CH3 था, तो हमारे पास ऑर्थो पैरा पे बनेगा, है ना? दिस यू ट्राई टू रिमेम्बर व्हेनेवर यू ट्राई टू मेक क्लोरीन. अगर क्लोरीन ऐड करना है, यू शुड सी द ग्रुप्स ऑन द बेंजीन. नेक्स्ट लास्ट थिंग टुडे वी विल राइट बेटा, लास्ट एक्शन लिखें. Preparation of alkyl halides. Take your time, write this. Take 1 minute, write, and write yes in the chat box after writing. चलो बेटा, last one we will see last reaction. Last reaction of today's class, preparation of aryl halides from amines. Same, same it is. Let's say we have NH2 group here, and this is known as aniline. इसको हम क्या बोलते हैं? Aniline कहते हैं. We have aniline group here, and this aniline, if I put in this aniline NaNO2 plus HCl at 0 to 5 degrees Celsius. Very low temperature we have to use in this reaction. इसको disonium reaction कहते हैं. And we make on the benzene ring N2 positive Cl. This is a salt, है ना? इसको salt है, इसका नाम है benzene diazonium salt. Diazo मतलब N2 will be azo compound, है ना? Diazonium salt, because it is positive Cl minus, it is a salt, and this is little bit of stable. See beta, aryl diazonium salts are more stable in comparison to alkyl diazonium salt. And earlier above we have written it was unstable, CH3N2 positive, and this is stable because positive will go in resonance of this benzene. So this is little bit of stable salt. ये थोड़ा stable है. And in this salt, if I put let's say in this salt, if I put in this salt, let's say I put CuCl, copper chloride, Cu positive, Cl minus, है ना? तो यहाँ पर N2 will go away and we will get chlorine, Cl, CuCl, है ना? Next, if I put in this salt CuBr, beta these are all reaction I am writing in a tabular form. And एक टेबल में लिख रहा हूँ so that I need not have to write all the reagent again and again. बार बार ये reagent नहीं लिखने पड़ेंगे. In one table you will understand. Let's say you have CuBr and we put N2 is again lost in this. These two reactions are known as Sender-Mayer's reaction. Sender-Mayer's. And you have to learn the name of this reaction beta. Aniline NO2 plus HCl will give you diazonium salt. If in that diazonium salt you put cuprous chloride or cuprous bromide, you will get these two. Next you have copper HCl. If I put copper and HCl together, we will get here chlorine. And if I put copper and HBr, if I put copper and HBr, I will get here bromine with N2 loss. These two reactions are known as Gaterman reaction. There will be many name reaction in your syllabus beta. Try to learn. The more you will write, the more you will. Last one, let's say you have Ki and you will make iodobenzene. Last one, देखते HBF4. If I have HBF4, हाइड्रोजन ब्रोमोक्लोरिक एसिड, यहाँ पर we get chlorine, है ना? इसको हम लोग कहते हैं, we call this reaction as Pfalz-Skimmen MANN, Pfalz-Skimmen reaction. Amen. And so if you want to make alkyl halides, if you want to make alkyl halides, aryl halides, so you have to go from aniline. You have to go from aniline to benzene diazonium to make chloro, bromo, iodo, and fluoro on benzene. This is one of the method which you can use. Write this within 2 minutes, then we will take our With this beta class is over, है ना? So we have covered all the preparation of aryl halides and preparation of alkyl halides. Tomorrow class we will study about SN1 and SN2 reaction. Next class I will teach you about SN1 and SN2 reaction. Another class will be our elimination reaction. So we will cover by this 2-3 classes we need. And last will be our chemical reactions of alkyl halides and alkyl. And if you have any doubt, you can raise your hand and I will unmute you. You can ask. These all notes I will share you, don't worry. This all notes I will share you, don't worry. You can raise your hand. Or you can write in the chat box here. Write in the chat box your doubts and I will tell you. Yeah, but I will share you the notes in the group, don't worry. So you have 10 minutes, you can tell me. 5 minutes you have more, you can tell me any doubts you have, you can raise your hands and you can ask. In today's lecture or day before lecture, 2 lectures we have done of alkyl halides.